But let's talk about how climate change could soon affect your flights across the Atlantic. Planes between Europe and North America will soon be spending much more time in the air due to the effects of climate change, according to a new study from the University of Reading. It's all about accelerating the jet stream. It's interesting stuff, this. The study's been led by Dr. Paul Williams, who's an atmospheric scientist at the university. Good morning to you, Dr. Williams. Thank you for coming on.
Good morning, David.
I was reading some of your work. It's fascinating stuff. How does this actually work, then, in plain English, for my benefit?
Yeah, well, as you say, it all boils down to this jet stream, which, apart from blasting storms across the Atlantic to the UK shores, and we've had plenty of those in recent weeks, it also plays an important role in aviation. And that's because the jet stream can blow at speeds of up to 200 miles an hour at the levels where planes fly. So a plane that's flying eastbound from North America to Europe, which is the direction the jet stream blows in, a plane will try and get into that jet stream and get up to a 200 mile an hour boost in its ground speed. In contrast, a plane that's flying in the opposite direction will try and get out of the jet stream and avoid it, but it can't do that completely, and it will always be influenced by the jet stream, so it gets slowed down. And as your listeners will know, if they've flown across the Atlantic, the flight time going over to the USA or Canada can be 1 hour or longer than the flight time coming back over to Europe, and it's all because of this jet stream and its influence.
So what does this mean for flights? And it simply means it's going to take a lot longer, as you say, it's going to take longer for us to head back.
That's right. We've got reason to believe now that the jet stream winds along the flight route between London and New York are getting 15% faster, and climate change is the reason for that. Climate change is not just about global warming at the bottom of the atmosphere, which is where we happen to live. The climate is changing higher up as well, and those faster jet streams are going to speed up the eastbound flights and slow down the westbound flights. So that's the key finding in a nutshell.
And what impact does this have for customers? I'm trying to work out the economics of this. Presumably it'll be cheaper for them to fly one way, or cheaper for the airlines in terms of the petroleum they'll be using, but it'll cost them more on the way back. It will equal itself out, will it?
Not exactly. As you say, jet fuel is a significant cost to the airlines, so they do try and minimise the flight time. In fact, just shaving a couple of minutes off a flight time can save well over 100 gallons of jet fuel. But it turns out that planes will be spending longer in the air on average. The cancellation is not exact, so round-trip journeys are going to increase. And if you add up those figures for all transatlantic aircraft, you come up with a figure of an extra 2,000 hours being spent in the air every year by planes, which is going to add over $20 million to their fuel costs. And it's also going to emit more CO2 into the atmosphere. In fact, the same amount as over 7,000 British homes. So this clearly has the potential to put upward pressure on people's plane tickets in the future.
Do the airlines know about this?
They do.
They do now.
Well, they certainly know about the jet stream, and in fact, they every day they calculate the fastest route by solving some complicated mathematical algorithm. So they absolutely know about the jet stream, and they very closely monitor it on a daily basis to make sure they're getting the best value for money from their fuel costs.
Fascinating work. Thank you very much, Paul. Good luck with your studies. Dr. Paul Williams, atmospheric scientist at the University of Reading. It's 18 minutes to 8. There's a story here on the front of The Independent this morning.